my name is Ben Guilford. I'm the owner of the Melbourne Fire Brick Company, and today I'm going to do a video demonstrating something that we get asked about a lot, and that is why can't I use normal pressed red bricks to build a wood-fired oven? We get asked that question on a really regular basis, so we thought we'd take the opportunity to demonstrate that and explain why it's not something that we recommend. So the question is, why can't we use pressed red bricks for building a wood-fired oven? Now, it's not because they can't handle the high temperatures. A lot of people think, you know, oh, pressed red bricks, maybe they're not rated to those sort of temperatures that a wood-fired oven can get to, and that's not the case. Pressed red brick is typically fired to 1200 degrees and over 1200 degrees Celsius when it's made. So technically, you can take it back over 1200 degrees again. What a pressed red brick doesn't like is rapid change in temperature, and that's called thermal shock. So going from cold to very hot in a short space of time is thermal shock, that rapid change in temperature. That's the difference between a pressed red brick and a fire brick. A pressed red brick is not really designed to handle thermal shock. It can handle high temperatures, but if you subject it to a rapid change in temperature, the brick will develop very small cracks, and those cracks propagate through the brick each time it experiences a new cycle of thermal shock. And eventually what you see in a pressed red brick is spalling. Spalling is when the face of the brick flakes off and exposes the surface underneath. You're going to see that if you look into any old fireplace. If you look at the back of an old fireplace, an old Victorian home or whatever, you'll see the back of the fireplace is all falling apart. It's sort of crumbling. And I always thought, before I started this business and started learning about this stuff, I always thought it was people throwing firewood in and they were hitting the back of the fireplace and breaking the bricks. And if you think about that for a second, if you throw firewood into an open fireplace, there's a recipe for like fire going everywhere. So that's not what's causing it. What's causing those bricks to fall apart is thermal shock. And thermal shock is causing spalling. Today we've got 3 bricks here that we're going to compare. We have one of our fire bricks, 38% alumina content. This is rated to 1350 degrees, and this is what we build all of our wood-fired ovens with. We've also got 2 pressed red bricks. We went to our local brickyard and said, look guys, can you give us a couple of pressed reds? Give us a new one, give us an older one, because you'll read on a lot of forums, people talk about the older pressed red bricks handle the high temperatures a little better, and there is truth in that because they're made differently. So we've got the 3 bricks here, and what we've done is we've cut a sample off the end of each brick and we've set them up in our thermal shock test rig. This thing is possibly the nerdiest thing that I've ever done. It was a project that I wanted to do for a long time, primarily to demonstrate this particular phenomenon, but also so that we can test different materials of our own and see how they handle thermal shock. The idea of the machine is fairly simple. This is a big furnace with a fully automatic system set up. So it opens the door, it'll put the samples into the furnace and hold them there for a preset period of time, which then of course they'll heat up, and they'll heat up very rapidly. They're going to go from ambient temperature up to about 600 to 900 degrees in about 30 seconds. Then we're going to raise the door, remove the samples, and we've got air jets along here that are going to cool the samples down, probably bring them down to around the 60 degree mark, again in about 30 seconds. So you can see here we've got our 3 samples of brick. This is the older pressed red brick. It's in really good shape. I'm not really seeing any cracking on that surface at all, even before we begin. A little spalling here, but that's to be expected. This is the new pressed red brick. You can see it's actually got a couple of little fractures, but it's solid. It's not going to fall apart on us. And then we have our fire brick down here, no fractures at all, very clean pressed surface. So these are now ready for us to start our thermal shock testing. I also got to do some very nerdy stuff with Arduino programming, which I hadn't done before and was a lot of fun. So anyway, without further ado, let's do this. So you can see the temperature's really rocketing up. Now this is we've only just started this a minute ago, so the furnace is still quite cool. We should get to maybe 400 degrees on this pass, so it'll take it from about 50 degrees up to 400 degrees in 30 seconds. Then it'll pull the samples out of the furnace and use these air jets here and here to cool the samples down rapidly. Now this is pretty extreme treatment of the samples, but the idea is we want to demonstrate what, say, 5 years of repeated thermal cycling can do to these different materials. Okay, so we ran our thermal shock test rig for more than 8 hours. Now this system has a cycle of 2 minutes, so that gives it 8 times 60, 480 divided by 2, 240 cycles, where we put the samples into the furnace, we ran them up to between 600 and 800 degrees in just under a minute, pulled them out, and then we cooled them down to around 50, 60 degrees, again, in around a minute. So the whole cycle was 2 minutes. The purpose of doing this test, as I said at the start, is not to say that you can't use pressed red bricks to build a pizza oven. In fact, if you look at old bread ovens, the big Scotch ovens, they used to be built with pressed red bricks. It was really common. In fact, it's probably rare to find one that is built with fire bricks. So I'm not here trying to tell you have to build it with fire bricks, but the reason they could get away with using pressed red bricks in those big old Scotch ovens is that they were heated up very slowly. They heated those ovens up over the course of a week. It was a big deal to let the oven cool down fully. You would only do that if you had to do some kind of major servicing to it. So pressed red bricks can be used in high temperature situations. Absolutely. I'm not saying they can't. But what they don't handle very well is rapid change in temperature from cold to hot and vice versa. So the strength that a fire brick has over pressed red bricks and pressed bricks of all kinds is that it can handle not only high temperatures, but it can handle rapid change in temperature. And believe it or not, a wood-fired oven, particularly, this is quite interesting, a domestic wood-fired oven cops a lot more thermal shock than a commercial wood-fired oven. And the reason for that is, in commercial applications, the oven's kept hot all the time. It's fired every day, and so it never has a chance to really cool down. So a domestic wood-fired oven actually experiences more thermal shock than a commercial wood-fired oven because it's usually heated up from cold. You'll take your oven from ambient temperature, let's say 25 degrees, you'll ramp it all the way up to 400 degrees plus in less than 2 hours. And you've got to consider the surface. It's not just about heating up all the thermal mass. The surface of the brick that's closest to the fire, that cops the worst thermal shock. So you'll see, again, if we use the example of old fireplaces, you'll notice that it's not the whole fireplace that's deteriorated, it's really mainly just the bit directly behind the fire, the part that was exposed to the most severe thermal shock. So, to reiterate, before we have a look at these samples, pressed red bricks are not going to explode if you use them in a wood-fired oven. They won't fall apart in your first week of using it, not at all. They'll probably last for several years, depending on how often you use it and how hard you push it. But eventually you are going to see spalling in a wood-fired oven that's built with pressed red bricks. The face of the brick is going to start to flake away and fall off. Fire bricks, they're designed to handle that, so they're going to be there forever. So that's the difference. So let's have a bit of a look at our samples and see how they fared. All right, so this brick here, you'll see has developed some cracks through here. Now they weren't there at the start of the day. In fact, this brick was actually looking really good at the start of the day. It was looking really solid. And I think there's another little crack coming straight up there. So I don't even want to touch them because these, you're gonna see how easily they're gonna fall apart. This one here, so this is the newer pressed red. This one's got a crack that's running all the way down to the bottom. Lots of little cracks and little fractures that I'm seeing, but that's one major crack that's running all the way through the brick. If we look at the fire brick, it's the color has changed, but there are no cracks in this at all. That is in perfect condition. Now that discoloration is caused by taking it to extreme temperatures. When we brought these bricks out, they were glowing on their edges. So let me show you, now they've had a chance to cool down, I'm just going to show you what happens when we touch them. So I'm going to start with this one here. And you see that? Mm-hmm. That is just split right through the middle there. And I think if I just give it, whoop, there we go. So there's your old pressed red brick. Now I would say that it has handled it a lot better than the newer one, and I'll show you that now. So this one here, just get this edge. It's actually holding together fairly well, but you can see if I do this, you can see that little crack along there? I'll just pull this corner off. Okay, and so that's what's happening, and I can see that crack is coming all the way through the other side. So if I get carried away, I can do that. Again, that's not really what you want to happen inside your oven. And we look at the fire brick, and I can twist this and poke it and prod it all I want. It's solid. And that's not because this has a much higher temperature resistance. This is rated to 1,350 degrees. These bricks, you could probably technically take them to about 1,200 degrees before they failed. It's not the high temperature that did this. What made this damage is the thermal shock. And that's what we're trying to demonstrate today. I'm nearly breaking the I can try and